Hello and welcome to Ought in Math. In this edition of Ought in Math, we're going to use what we've learned in this chapter and also in previous chapters talking about Pythagorean identities to solve more difficult trig equations. All right, so let's talk some background first. Cosine squared x versus cosine x squared. So just in order to clarify, cosine squared x is equal to cosine x times cosine x, whereas cosine x squared is equal to cosine times, in parentheses, the quantity x squared. A lot of students confuse this value with the value on the bottom left, cosine x squared. So please, when you're evaluating, a lot of times, at least for the problems that I've seen, it's mostly cosine squared x, not cosine x squared, so we can differentiate these two while we're evaluating. All right, so I want you to take a moment and factor this quadratic, 2x squared minus x minus 1. Right, you should get 2x plus 1 times x minus 1. That should be a pretty quick transaction for you. Please also remember, I'm not asking you to solve. There's no equation here. I'm just asking you to factor, so please differentiate between factoring and solving. All right, so now I want you to factor this. Right, you should end up with 2 cosine x plus 1 times cosine x minus 1. And you can see the only thing that we've done here is replaced x with the prior problem. We've replaced x with cosine of x. All right, so this is essentially a quadratic, a trig quadratic. And we can, if this were an equation, we could solve for this problem, which in fact is what we're going to do. So for the values between x, between 0 and 360, please solve for this problem. I'll pause here. All right, you should get 2x plus 1 is equal to 0. And cosine, after you factor, cosine x minus 1 is equal to 0, which leaves you with cosine x is equal to negative 1/2. And cosine x is equal to negative 1/2 at 120 and 240. And also cosine x is equal to 1 at 0 degrees. Okay, now I'm going to walk you through the process in this example of solving a more difficult trig equation. Please give yourself lots of room to solve these problems. At first they are difficult, or might seem difficult, but over time they get a little bit easier as you try to figure out how to simplify, evaluate, and solve. All right, so I'm going to take cosine 2x, and a lot of times the strategy would be to rewrite your double angle or half angle formulas, if you can, in terms of one variable with the other variable that you have. So cosine 2x, I have 3 choices here. One that involves just sine, one sine and cosine, the other in just cosine. And since I have a cosine on the right-hand side of the equation, I'm just going to rewrite my double angle formula for the value that has cosine. So 2 cosine squared x, and this is my first attempt. 2 cosine squared x minus 1 is equal to cosine x. Of course, sometimes it might not work out the way that you want. So you can always start from the beginning and use a different formula if you so choose, if it doesn't work out for you. So 2 cosine squared x minus 1 is equal to cosine x. Now this looks like a quadratic to me. I'm going to subtract cosine x from both sides. 2 cosine squared x minus cosine x minus 1 is equal to 0, which leaves us with which leaves us with the same factored value that we had before, 2 cosine x plus 1 times cosine x minus 1. And of course, we're going to end up solving for the same equations that we had before, and the same answer, x is equal to 0, 120, and 240. All right, so now it's your turn. See if you can figure out the value for x that makes this equation true or valid. So tangent 2x plus tangent x is equal to 0. I'm going to pause here while you work on this. All right, so you're going to get the tangent double angle formula. I'm going to move the tangent x to the other side. I'm going to multiply the denominator of the first value by the value on the right. I end up with 2 tangent x is equal to negative tangent x plus tangent cubed x. I'm going to rewrite the expression with my tangent cubed x and everything actually on one side and consolidate. So I end up with tangent cubed x minus 3 tangent x is equal to 0. Now you're going to distribute out the tangent x. Tangent x times tangent squared x minus 3 is equal to 0. I'm going to use my zero product property to solve. Tangent x is equal to 0, or tangent squared x minus 3 is equal to 0. I end up with x is equal to 0, 180 on the left. Tangent squared x is equal to 3. Take the square root of both sides. I have to add plus or minus to the right side. I end up with tangent x is equal to plus or minus root 3. tangent x is equal to plus or minus root 3 at 60, 120, 240, and 300. So my answers in total are 0, 60, 120, 180, 240, and 360. All right, excellent. Let's move on. All right, tangent squared x minus tangent x. Let's see if you can solve for this. Okay, so what I don't want you to do is I don't want you to divide by the variable. And the reason why we don't divide both sides by the variable, this would seem like a simple way to resolve this problem and end up with tangent x is equal to 1. And that's because if you do this, you end up potentially eliminating one of your values. So if I were to factor this properly, I'd subtract tangent x from both sides and end up with tangent squared x minus tangent x equal to 0. Distribute the tangent x out. Now I have tangent x is equal to 0, tangent x is equal to 1. And so you can see from the prior problem, tangent x equals 1. I had basically two solutions. And now I'm adding potentially two more depending on the range of values that I'm looking for x. So please make sure that you do not divide by a variable in this case because you can and potentially will eliminate one of your answers. All right, so let's move on. I'm going to give you another problem. Solve sine x cosine x is equal to 1/2 for between 0 and 2 pi. I'm going to pause here. All right, so I'm going to rewrite sine x cosine x is equal to 1/2 and multiply both sides by 2. Pretty straightforward. Actually, this was one of the easier problems that took me a while to figure out just because I didn't know how to separate sine x cosine x. And in fact, you didn't have to. You're just going to multiply both sides by 2. 2 sine x cosine x is equal to 1. Sine 2x is equal to 1. And that's the case for pi force and 5 pi force, between 0 and 2 pi. All right, next one. Tangent 2x is equal to 3 tangent x. All right, I'm going to rewrite this as 2 tangent x over 1 minus tangent squared x is equal to 3 tangent x. 2 tangent x is equal to 3 tangent x minus 3 tangent cubed x. So I'm going to multiply the denominator by both sides. I'm going to simplify 3 tangent cubed x minus tangent x is equal to 0. I end up with tangent x times 3 tangent squared x minus 1 is equal to 0. Very similar to the prior problem that we did, but in this case you end up with tangent x is equal to plus or minus root 3 over 3 instead of just root 3. And then here are your answers. Tangent x is equal to 0, pi, pi 6, 5 pi 6, 7 pi 6, and 11 pi 6. All right, moving on. Okay, let's solve for this problem. I'm going to pause here. All right, we're going to rewrite cosine 2x as cosine squared x minus sine squared x. So you're going to find sine squared x minus cosine squared x. There are I've seen different ways to solve this problem. So this is the way that I worked it out. 6 sine squared x is equal to 2 cosine squared x. I'm going to divide both sides by cosine squared x and then by 6. I end up with tangent squared x is equal to 1/3. Take the square root of that value. Tan x is equal to plus or minus square root of 3 over 3. And then I end up with pi 6, 5 pi 6, 7 pi 6, and 11 pi 6 as my answer. Okay, one more, and then I think we're going to be done here. 3 sine x is equal to 1 plus cosine 2x. Okay, I'm going to rewrite this as 3 sine x is equal to 1 plus 1 minus 2 sine squared x. 2 sine squared x, and I'm going to rewrite everything on the left-hand side of the equation. 2 sine squared x plus 3 sine x minus 2 is equal to 0. Factor 2 sine x minus 1 times sine x plus 2. I end up with sine x equal to 1/2. Sine x is equal to negative 2. I know that the value for sine can't be greater than 1. So I know sine x is equal to negative 2. I will never get a value of negative 2. So this particular value can never be 0. I end up with sine x is equal to 1/2. And the values where sine x is equal to 1/2 is pi 6 and 5 pi 6. All right, that is it for this edition of Otten Math. Please come and join us next time when we're going to start talking about vectors in Chapter 12.